Hello, everybody. Mr. Rubo here. And today we're going to look at log properties and also some sum and difference of logs. So there is this warm up here that I want you to try out first to kind of discover some of these properties. So I give you, let me just explain this real quick before I have you go try it. I give you what each log base 10 of each of these numbers is equal to. So if you literally type in a calculator, you'll see these are the decimal equivalents, or I should say decimal approximations um, of all of these. So what I want you to do is literally, I'll do the first one for you. So it says find each of the following values in decimal form. So log 2 is 0.301. Log 3 is 0.477, and I want you to add them together. And yes, I'm trying to ask you to do this without a calculator. So try your best, and yeah, go ahead and do all of the operations here with the different logs. Pause the video, come back to it, and yeah, we'll go over the answers and then maybe see if you notice any patterns here. So yeah, pause the video and try it out. Okay, so hopefully you tried it out and you hopefully got these as your answers. So 0.301. This one should have been 0.903. This one should have been 1.079. This one 0.602. This one 0.954. This one should have been 0.477. And this one also 0.477. Okay. And I was able to do all of those real quick. I didn't have them written down or anything because I knew the log properties already. And hopefully you took a second and actually, like, after you figured out all of these, looked back and maybe you saw something, because all these numbers ended up happening multiple times, or they happened, I gave them to you and they were also your answers. So you can kind of see here, this guy, our first one, was the same as log 6. So I'm actually going to put that here, maybe to see if we can see a pattern. So log 6. All right. Then 0.301, well, that's log 2. So log 4 minus log 2 ended up giving me log 2. Here, 3 times log of 2 ends up giving me 0.903, which is log 8. Okay. This one is log 12. Okay, and I'm just matching the numbers up here. All right. 0.602 ends up being log 4. Okay. For this one, this is the same as log 9. This one, log 3, and also the same for this one, log 3. So you kind of look through this and maybe you notice some patterns, maybe you don't. But we're going to go through them anyways, just because these will make a lot of things much easier for you and allow us to do some really interesting things with logs. So if we look, and we'll kind of go through it real quick. If you look at the first one, when it was addition, 2 times 3 is 6. So the other addition one we had was number 4, and 4 times 3 is 12. It ends up, that's how it works, is adding 2 logs together, you multiply their insides and keep the log the same. Okay. And then if we look at the couple subtraction ones, we actually have 3 of them, right? Log base 10 of 4 minus log base 10 of 2. That ended up giving us log 2. Log 9 minus log 3 ended up giving us log 3. Log 12 minus log 4 ended up giving us log 3. If you notice this pattern, 4 divided by 2 is 2, 9 divided by 3 is 3, and 12 divided by 4 is 3. So subtraction gives us division. And then the last 3 here all had a number out in front. This one might be a little tougher, but especially if you look at this, you might realize, oh, Well, this is just, if I move this 3 up here, log 2 to the third, 2 to the third is 8. Right? Here, move it up. 3 squared is 9, and 16 to the 1/2 is 4. So that's another property. That's the power property of logs. All really nice properties. So let's go ahead and talk through a bunch of these. Now, we actually did properties 3, 4, and 5. So let's just put them in words. So you have log base A. If you're adding, it's the same as multiplying the two insides together, but the log stays the same. Okay. Subtraction, the property is division. So m over n in this case. And then here, if you have a number out in front, you can put it as the power. It's called the power property. Okay. So yeah. The other properties, the first two are basic ones. These actually we saw with the graphs. If you think back when you substitute 1 in on the graph, you ended up, that was your x-intercept, so you got 0. So this is, if you ever have a 1 here, no matter what the base is of the log, you get 0. And then if the bases are the same, you get 1. Again, that kind of goes back to the graphs. Okay. And then these other two properties that came before, these are, the reason they're listed before is because they're really nice ones. If the base of an exponential and the base of a log, whether it's written with the exponential first and then the log in the power, or the log first and then the exponential inside of the base, it doesn't matter either way. They both cancel out, and you're left with either the number inside of the log, so in this case m, or you're left with the power, in this case r. Okay. And then the last property is really a equation equal property, equality property, which is basically if you know two things are equal, then if you take the log of both sides, you still have something equal. That's an n, not an m. All right. So that last property we've actually used already with solving. More so the other way, right, where we cancel out logs and go the other way. Sometimes you might want to take the log of both sides, and that's really helpful. So make sure you have all these down. These are all your basic log properties. And honestly, most of them you saw last year, except for maybe the addition and subtraction ones. So, all right, so let's go ahead and get some practice in of these. So, yeah, let's just do a couple that are straight from there. Here we see log base 7 of 15 is in the power, but it's 7 is our base. Because both bases are the same, they cancel, and you get 15 as your answer. And it's as easy as that for that property. Okay. Number 2, same idea. It's same base. So the base of the log, you can see it's a little subscript, so it's written smaller. The base of our exponent, they end up being the same, so you can cancel those out, and your answer is just 6. All right, so now number 3, here's where we have to do a little bit more work, but as long as you remember, subtraction is, we're able to write it as the division of the two things. So we end up getting log base 8 of 16 over 2, which log base 8, 16 over 2 is 8. And look at this, we're actually using two properties here. Log base 8 of 8 is 1, because it's the same base as the number next to it. Okay. And yeah, there's those properties. So that's hopefully not too bad. Okay. Actually something before I go on to the next ones, because those are going to get a little tougher, but not horrible. I do want to mention, because I didn't mention it here, with the warm-up, all of these are base 10. These are the common log. So we don't, because it's base 10 and we're in a base 10 system, we don't write the number for 10 all the time. So if you just see something that says log and no subscript, it means the subscript is 10. Okay, and that should hopefully be reviewed from last year, but just as a reminder. All right, so now let's get to the ones that, for some reason, these always throw students off, but they're really not that hard, okay? So they tell us natural log of 2 equals a, natural log of 3 equals b. We want to use the properties to write each log in terms of a and b. So our final answers should only have a's and b's in them, and then maybe some numbers, but it should not have any logs in the answer. For some reason, people love with these ones, like they see once they might do the right work, but then end up putting a or a natural log of a. We don't want that because a is natural log of 2, so it takes the natural log away as well. So here we're going to use our property because right now we have natural log of 2/3. We want natural log of 2 and natural log of 3 to show up. We don't have that yet. We have natural log of 2/3. So to break this up, because it's division, we can break it up as subtraction. So the properties work both ways. We have it as division. We can pull it apart into 2 separate logs that are being subtracted. And now natural log of 2 is a. Natural log of 3 is b, and I have my answer a minus b. Okay, so your goal with these types of problems is to make 2 and 3 show up, not just 2 and 3, sorry, natural log of 2 and natural log of 3 to show up in the problem, most likely by using your log properties to break up the log into usually as many pieces as you can, and using different properties to do that. So here, 12, I could break this up in kind of 2 ways. So there's kind of 2 mindsets here. One, you could say, oh, let me break it up to natural log of 4 times 3, right? 4 times 3, that's 12. So I haven't done anything. And then because I have multiplication here, I can break that up, right? Natural log of 4 plus natural log of 3. And I finally got my natural log of 3, but natural log of 4, it's not 2, right? I need 2 to show up. So then what I'm going to do is say, oh, well, natural log of 4 is 2 squared. And then because this is natural log of 2 squared, I can pull this 2 to the front. And now I have natural log of 2, natural log of 3, and I can write my answers in terms of a's and b's. So there's a 2 out in front, then a for natural log of 2 plus natural log of 3, which is b, and there is my answer. Okay. The other way you could have also done this is literally just think, oh, this is really, breaking this down to just 2s and 3s. It's 2 times 2 times 3. You could say, oh, well, I'm multiplying and multiplying, which means it breaks up by addition twice. Natural log of 2 plus natural log of 2 plus natural log of 3. And then you say, oh, this is a plus b. A plus a is 2a. And there you get the same answer. So either way you want to think of it works for me. All right, so here, let's go ahead and do the same idea. Now, this one's a little tougher of a number. 48, it's a little bit bigger. So let's just break it up to as small as it can get. Now, the other thing is this fourth root, I'm going to change to a 1/4 power right away. So that way I don't have to deal with that. But now, let's kind of figure this out. So it's 16 times 3 is the what makes 48. If you want to keep breaking it down, 16 is made up by 2 times 2 times 2 times 2, or 2 to the 4th, times 3. That looks like a minus sign. I'm going to rewrite that more dottish. Okay. All right. So now I have to do something with this 1/4 power before I can break this up. Well, that thing I'm going to do is pull that 1/4 to the front. Okay. And now, because I have all of these multiplications, what I'm going to do is write it as 1/4 times natural log of 2 plus 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 natural log of 3. And again, now I can see, oh, I've got all of these guys that are now my a's and my b's. So I got 1/4 a plus a plus a plus a plus b, and 4 a's plus b. And then I let's go ahead and multiply this out because I can already see some nice math here, right? That's just going to be a plus b over 4. And there's your answer. Okay. So yeah, that one a little tougher just because of the bigger number, but it's still the same idea, right? You want to break them up to where you can see just 2s and 3s. And then if it's multiplication, break it up by addition. If it's subtraction, if it's division, break it up by subtraction. If you have powers, move them to the front. Okay. All right, so then we get to some questions where they just want us to break them up as much as possible. So they say here, write the following as the sum or difference of logs and express powers as factors. Meaning if there's a power, it needs to come to the front to be multiplied by it. So what you want to look here first is just kind of look at the problem, look for any powers, right? We have a power here. We also have a secret power here, right? The square root, remember, is really a 1/2 power. But then we also have multiplication. It's x squared times square root of 1 minus x. So let's do looking at this, I'm going to deal with the times first, that multiplication. So I'm going to say natural log of x squared plus natural log of the 1 minus x to the 1/2. Again, switching that up to a power just so I can clearly see that's a power, because then I have to do something with that, which now all I have to do is bring these to the front. And yeah, 2 natural log x plus 1/2 natural log of 1 minus x. And there we go. We can't break up this anymore because the first log is just an x inside. Second log is 1 minus x. We don't want to break it up because there is no multiplication or division, no powers left. So we're good. All right. And then if we look at number 8 has a lot more stuff. But again, we kind of just look at what's here. So there's 5 times x times the square root of 3 times x, and then x divided by x minus 4 to the third. So I'm going to deal with all the multiplications first, or most of the multiplications. You'll see this one I can't deal with quite yet because of that 1/2 power. But I can go ahead and say natural log of 5 plus natural log of x plus natural log of 3x to the 1/2. Again, I'm going to kind of do that 2 things at once there. Break it up and put it as a power. And then the division I can rewrite as subtraction of that. Okay. And now this first one, nothing changes. Natural log of 5 is natural log of 5. Natural log of x doesn't change. This 1/2 comes to the front. Okay. And I still have multiplication that I have to deal with that I will deal with in a second. Minus, and then this 3 again goes to the front of the log. And there you go. And then the last thing, like I said, is this multiplication here. So you just want to make sure, and I'm running out of room, but I'll fit it in here. So natural log of 5 plus natural log of x, nothing changes there, plus 1/2. And then this can split up to natural log of 3 plus natural log of x minus 3 natural log of x minus 4. And now you check all your logs, no multiplication or division or powers, so we're good, right? Natural log of 5, natural log of x, natural log of 3, natural log x, natural log x minus 4. No multiplication, no division, no powers, so we're done. Okay, and that's what you want to do with these problems, is you want to just start pulling them apart and then just check what you have left and see, can you pull it apart anymore? Okay, so with this last one, we have multiplication here, right? X times x plus 2. And then we have the division, and we have this power, so we got to deal with all of that. So let's do with the multiplication and division. So it's log x plus log x plus 2, right? That deals with the multiplication of those two. But then we're all divided by log x plus 3 to the second. And then we look at log x, that's fine. plus log x plus 2. That one's also fine, but then this guy has a power. So we got to pull that to the front. And now we're good. Because they all, no more multiplication, no more division, no more powers. So we're good. All right. And then the last type of problems, you'll see it says write each expression as a single log. So this one, we're doing exactly what we just did, just the other way. Okay. So our final answer is going to be just one single log, where with the last three examples, these guys, they wanted us to pull them apart as much as possible. Now we want to do it the other way. We want to condense these. We want to make them just one single thing. So again, you're going to do that as best as you can using our properties. So we have two logs. We want to combine them into one. First thing you want to check is to make sure that both the logs have nothing in front of them. So in this case, we're good. And then we deal with the operation in between. So subtraction means I can rewrite this as division. So I can say square root of x over x to the third. And that's perfectly fine. That's a single log. Yeah, we could simplify that a little bit with exponent rules, but I'm actually okay with it as it is. Okay. And then with number 11 here, this is where sometimes students make some mistakes because there's numbers in front of the logs. So to deal with those, we have to get rid of them or get them out from the front first. The way we do that is the power property. So I move it up to the power. For this one, same thing with this one. Now, for the 1/2, if you want to, you can write it as the square root, or you could just write it as a 1/2 power. I don't care. Whichever one makes more sense to you. Both are 100% correct. And then again, now they're both got a 1 in the front. We're subtracting is our operation in between. So subtraction means division. So the top. And if you wanted to simplify this, you can. I honestly am okay with you leaving it alone. If you left it alone, that's totally fine. So I'll leave this answer as one possibility. Right? So both of those are powers. So that's perfectly fine. If you wanted to simplify that a little bit, it would be 25x, right? 5 squared, and then x to the 6th, because you multiply. And then you could do 2x plus 3. And this would be the only way you simplify that. But again, I would actually have accepted either of those two answers for this guy. Okay. So yeah, there's your log properties. We'll definitely get more practice of these, but yeah, they're hopefully not too bad. Try to simplify them as much as I can, but yeah. All right. Well, thanks for watching, and have a good day.